So my name is Ray Nicholus, and I'll be talking about the File API today. And why am I going to be talking about the File API? Well, I've been, Mark and myself, Mark's doing another presentation tonight, he's in the back, have been working on FineUploader for a while. I've been working on FineUploader since August of 2012, and that has forced me to learn a lot about the File API and how the implementations vary between the browsers and how you can deal with files and uploads without File API support. So I have some useful information about that, I hope. And hopefully what you'll get out of this is, obviously a better understanding of the File API, but more specifically, maybe you'll be able to take some of the demos, some of the examples that I'm going to be showing tonight, and maybe extend them to do useful, interesting things for your own web apps, and maybe create a library that uses the File API. The File API is, you can do a lot of things with it, but the primary focus, generally speaking, is uploading. So a lot of the examples I'm going to be working with will be centered around uploading, but not all of them. And I'm going to be live coding my examples tonight, so that usually doesn't go well. So when I make a stupid mistake and I'm fumbling around and I obviously don't know what's going on, if it's obvious what I'm doing wrong, just shout it out so that I don't look like an idiot for too long. All the live coding stuff will be the client-side code. There's a server portion to this, but it's really simple and it's sort of doesn't matter for this presentation. It's just handling multi-part encoded requests. It's only ever used when I'm uploading files, so I'm not live coding that. But the server side is just a node server running Express. It's like 40 lines of code. So nothing too interesting there. So before the File API is the first thing I want to talk about. And the File API, and don't worry, I'll talk about what the File API is, but the File API doesn't exist in IE9 and older, Safari 5.0, Android 2.3 or older, or iOS 5. In fact, in iOS 5, I don't believe there's even a file input element. So you can't do anything with files in iOS 5. When I talk about Safari, I'm always talking about Safari for OS X, not Safari for Windows. Don't use Safari for Windows. There's no reason to use that. Apple has pretty much stopped development of that anyway. So when you don't have the File API, you don't really have access to files in the browser. For the most part, if you want to do anything with the file, you need to send it to the server first, and then the server does that stuff, and then it returns information to you. So that kind of sucks, but that's the way it was for many years until the File API came along. So I'm just going to briefly, cover two quick things here. Without the File API, the way you would upload a file is just a simple form submit, and there's some obvious problems with doing that. So we're just going to create we'll call it form. Yeah, that's fine. So we're just going to create this form here. Method is going to be post. And our upload endpoint is uploads. Let's get some space here. And this is going to be a multi-part encoded upload, and that's pretty much required if you're going to be sending files. We'll just add a little text field here. And we'll add our file input field here. That's just and of course we need a submit button. And I think that is all we need. So we'll just go to that page. So we have our form here. We're going to choose a file. Whatever, doesn't matter. There's our name. We're going to submit it. What happened here? Name undefined. Apparently something happened to my server. That's nice. That's really good. What did I do wrong here?
You have a name for your file.
Oh, thank you. That's why you guys are useful for this, because I'm going to forget this stuff. Right. Yes, this needs to have a name. If you don't have a name field, it will not be sent in the request. That's correct. The name of this needs to be file, because that's what our server is expecting for the file. Let's try that again. Okay, so we sent the file to our server, but the page reloaded, and that kind of sucks. That's not very user friendly. Here's our file. So the way to sort of get around that and do an AJAX-y file upload without the file API is it's actually really simple, even though it seems a little bit kludgy. All you need to do is create an iframe like this. Give this a name of FineFineUploader, and we need to make it hidden, and then on our form we're going to target that iframe, and what that target attribute means is the response from the server is going to be loaded into that iframe. So what's going to happen here is we're going to
file uploads is what you called it.
frame uploads. Thanks. Just gonna get over here. There. Oops, gotta go back. Send a different file. So if we look in the network section here, we can see that an upload request was sent. It's a multi-part encoder request. The file is on our server over here. There it is. And if we look at the hidden iframe, we'll see that the response from the server is indeed in there. It's going to be in the body of the document. There it is. Okay, so that's fine. If you want to do sort of an AJAX-y upload without the file API, that's kind of what you're limited to. You can't do anything with the file bytes client side. You have complete dependence on the server. So then in 2009, the file API came along, and the file API is a W3C specification. Right now, it's in the last working call draft. And that's fairly close to the end of the process. It seems a little strange it's only there since 2009, but next is call for implementation, proposed recommendation, and finally a recommendation. And the file API just essentially allows you to read, select, or access, or modify files in the browser. And I'm going to talk more about what modify means. There's sort of a caveat with modifying files. So the file API is supported in Chrome/Opera, and when I talk about Opera, I mean Opera 15+. If you were sort of an Opera user, you might know that Opera used to use the Presto engine, and in Opera 15 Presto Changeo, now they're using Blink. So Opera is essentially Chromium at this point, and as a result, Opera has pretty much all the features that Chrome has. So you get a lot of the same features that you get in Chrome for Opera for free, which is kind of nice, I guess. And Safari 5.1, which technically supports the file API, the first version of Safari to support the file API, is an incomplete implementation. And the big missing piece is file reader support, and I'll talk about what file reader is. The other thing that's sort of strange about Safari 5.1 is that various builds of Safari 5.1 are missing the slice method on the blob prototype, and maybe you don't know what that is now, but that'll be clear as I go on in my presentation. So Safari 5.1, again, incomplete implementation of the file API. So now I'm going to sort of talk about the basics of the File API. And the File API is made up of two top-level interfaces. And the most important interface for the File API is the blob interface. And with the blob, you can represent any file content at all. And here's sort of what a blob object is. There's a size property, which is the size of that blob in bytes. There's a type property, which is a string, and that's just the MIME type of the contents of the blob. And then the blob prototype is a slice function. And that slice function allows you to chop up the blob into smaller pieces. For large blobs, that might be useful to overcome request size limitations on your server, or if you are uploading a very large blob, it might be useful to slice it up into pieces so that if there's a network error halfway through the upload, you don't have to start over at byte 1 again. You can start over with the last chunk of the blob. It's also useful if you're only interested in a certain portion of the file, like if you're identifying a file by looking at the magic bytes in the header of the file. There's no reason to read a giant file if you only care about the first 3 bytes. So you can slice off those first 3 bytes and read them. And I'll actually be covering that as well. So it's really easy to make your own blob. This is contrived. This is really trivial. But I just want to illustrate how you create a blob. So there's the blob interface as a constructor. You can pass in an array of strings. You can pass in an array of other blobs to make a blob. You can pass in an array buffer. An array buffer is just a representation of bytes. You can't do anything with an array buffer. You need a typed array, which is a more specific representation of bytes, like an unsigned 8-bit integer. I think is also called a data view. But you can have a mix of these things as well to make up a blob. And then, for the most part, when you construct your blobs, you're going to have this object, and you're almost always going to make use of the type property, which is the MIME type, the content type of the blob. And in this case, text plain is most appropriate. Now, earlier on in the File API spec, there was this object called Blob Builder. And Blob Builder was how you used to construct blobs. But that has been deprecated from the spec, and now this is the way you want to construct blobs, using the blob constructor. This just seems more natural, more intuitive. Not entirely sure why Blob Builder ever exists, but they realized the error of their ways, and it's gone now. Although some really old browsers still use it. I think PhantomJS, which is Qt WebKit, I think that still relies on Blob Builder, if I'm not mistaken. So, why does any of this matter? So we've just created a blob with the word hi in it. That doesn't seem very useful. Well, like I said, that was a really trivial example. You can do some really neat things with blobs, but we're going to start out slow. We're just going to create a real simple blob, and we're going to send it to the server via XHR. And then after that, we're going to essentially create our own multi-part encoded request, as you would create if you submitted a form with a file input in it, and send that to the server as well. So I'm going to create an HTML file here. I'm sort of doing everything in the HTML file just so I'm not hopping between JavaScript and HTML and CSS files. So it's a little bit easier to follow. So we're going to start, we'll just add a button here so we can trigger the upload. We'll start by constructing a blob, just a real simple one. That'll be our blob. And the type is text plain. Don't worry, we'll be doing much more interesting things soon. Did I get that right? Yeah. Now we're going to create our XML HTTP request instance. Yes, I do. We're going to send a post request to our uploads endpoint. And now, one way you can send this blob is you can just do this. And what that's going to do is it's literally going to send a post request where the only contents of the payload is the blob, and that's it. And if you're sending an upload to maybe a REST API, that's probably what you want to do. Like if you're uploading to S3 or to Azure directly from the browser, this is what you'd have to do. You'd be a put request, probably not post. But in most cases, you might not be doing that. You might be integrating, sending this file to an older server that expects it to be a form submit. It's going to expect a multi-part encoded request. And that that is easy to do using this form data object, which is part of the file API. So we're going to create a form data object. And file. And so now we're going to replace this XHR send blob with form data. And that's what we're going to send.
Should the new form data have parens after it?
Doesn't need it.
No.
So let's go to blob. Network. I didn't actually add a click handler, but who cares? It's just doing it as the page loads up. So it sent that blob, and here's our multi-part encode request, text plain. The file on our server is, if we look, oh, it's blob. Well, that's not very helpful. That's the thing. If you look at this multi-part encode request, a blob has a file name of blob in all browsers. The main reason for that is the blob object doesn't have a name property. So this is just sort of what the browser gives you when it constructs the request. But you can change that. The frame or the form data append method takes a third parameter, and that would be your file name for something like this. And if we look at that multi-part encoder request again, we can see that the file name parameter is now indeed hi.txt, and that's what we got on the server. So I'm going to talk about like slicing a blob into pieces. So let's pretend that this hi there was actually a really big file, and we needed to split it up into smaller pieces. Just for an example, we'll split this up into 4 equal pieces of 2 bytes each, and we'll send each piece in a separate XHR request, a separate post request. Because generally speaking, if you're going to split a blob into pieces, you're not going to send them all in the same request, otherwise why even bother splitting it up? So we're just going to move all this into a for loop. So then blob.size is 2. And what we're going to do is a blob.slice I, and then I divided by 2, and we're going to change this file name to maybe a specific file name for that particular slice. And just for make it easier on the server, maybe the server wants to know what particular part of the file it's dealing with, we can just add another parameter with a request. We'll just call it part. So this will be the part index. And we'll go ahead and send that. And we got these 4 requests. Let's make this a little bit bigger. Probably should zoom in too. So we got these 4 requests, one for each slice. High 1, high 0, high 1, and so on. If we look on our server, sure enough, we have those 4 blobs, those 4 pieces. Oop, I think I actually forgot to do something here. Form data append. Something got messed up here, because there's not actually any data in these files. What's that?
Send the I part, not the I, divide by 2 part. So do the slice.
Oh, plus. I think this should be plus 2, right?
And then part should be just I.
Yeah, you're right. It's fine. Okay, so now hopefully we'll have pieces here. Right, hi, and then all the pieces. Great, thanks. So that was really simple and kind of useless, but you get the idea. What we did there is we essentially did the same thing that a form submit would do and a little bit more. So something a little bit more interesting we can do with blobs. And the first part of this example is not entirely necessary, but I want to demonstrate something else you can do with XML HTTP request. One neat thing you can do with XHR is you can get a resource from a server and you can have XHR can turn that into a blob for you. So we're going to do that, and then we're going to take that blob, we're going to transfer it to an image element, we're going to draw it onto a canvas. The underlying image is going to be an upside down tree, and then we're going to flip it on the canvas, and then we're going to show that on the canvas. The next step will be actually uploading that right side up tree back to the server. So we'll call this flip tree. We'll set up our canvas here. Let's see, how big is this? What's the dimensions here? It's 544 by 444. This is just for display. And we'll create an image here as well. So the image is going to hold our upside down tree, and then the canvas is going to where we're going to actually render the right side up tree that we're going to flip. So we're going to get that tree, upside down tree file. And that would be upside down tree.jpg. And I want to know when it's done. Let's actually remember to send that GET request. So one thing we're going to do here is we're going to tell XML HTTP request to turn this file into a blob for us so we can do something with it client side. So there's with the response type property, there's a new value which is blob. So over here, we are actually going to have that upside down tree as a blob. Response. And let's start by just throwing that into the image tag. And one thing we need to do to actually render this blob onto that image element is we need to turn it into a URL. So the URL object on the window has a create object URL, which will give us a URL that points to that blob, and that URL is good for as long as the document itself stays in scope. Once the document goes out of scope, that URL is no longer useful. But that's okay for this particular demo. So we're going to do, we'll just do, let's get our image first. So we're going to do URL.create object URL, and we're going to pass in that tree blob. And that should work. Fliptree.html. And we have the upside down tree. So now let's draw it onto the canvas and flip it, and like I said, in our next step we're going to actually upload that. So we need to know when the image is actually rendered when it's done loading. So we need to add a load handler to this image. And let's get our, let's just do the canvas thing here. Let's get a handle on our canvas. And we need to get the canvas context.
Widen that middle a bit.
Oh, sorry, yeah, I meant to get rid of that. Is that better?
Yeah, thanks.
Canvas context. Okay, so first we need to. It's kind of working with Canvas is kind of awkward. So some of this might seem kind of weird, but it's not entirely the point of the discussion. I'm just gonna save.
CTX.
Thanks. Dot, scale. This will flip it. I'm going to draw it. And then we have to do this restore. So now we're going to have, hopefully, our tree upside down and then below it the right side up version, or next to it, whatever. So there you go. Now, all of this here really wasn't necessary. You could have just as easily created an image element and set the source of it, attribute of it, to be upside down tree.jpg and added an onload handler. But I just sort of wanted to illustrate that you could get a blob from an XHR GET request pretty easily, thanks to the file API. So the next step is to actually do something with this blob, and the natural thing to do is, instead of having our server flip this tree for us, we'll use the client's resources, flip it, and then just send the file to the server. And the easiest way to do that is the toBlob method on the Canvas element. Unfortunately, the browser support for toBlob is not great right now. And strangely enough, Chrome doesn't even support it. I think the only browser that supports it is Firefox. So what you need to do to make that work is you need to turn the canvas into a data URL. You need to get a base64 encoded representation of that data URL, and then you need to convert it to an array buffer, and then you need to throw that array buffer into the blob constructor. And I'm not going to do all that here. What we'll do, because that's a nightmare, I'm gonna rip some code out of FineUploader, which does this, and copy it, and then we'll just see our blob uploaded to the server, our right side up tree. Yeah, it's kind of crazy. Gotta fix this. I think I did miss the first line, thanks. Yeah, that didn't look right. We don't care about strict here.
What does FineUploader do?
FineUploader it's just an upload library that allows you to do cross-browser file uploads. There's a bunch of other features, like it'll scale files in the browser for you. It'll generate previews. It'll auto retry failed uploads. It has a resume function where if your file fails and the browser closes or your computer blue screens, you can pick up where you left off when you reopen the browser. A bunch of other stuff. Okay, we have no QQ each in here, so just patching up this code so it'll work for us. And not this. I think that is probably, what is that, a semicolon for good measure? I think that's probably going to work. Famous last words. So now that we have this canvas, this right side up image drawn on the canvas, we are going to do a what is called data URI to blob. And we get our canvas to data URL. I think this is JPEG. That's probably good. can upload that. Add our upside down tree to the form data object. Probably should name that something other than blob. Let's give it a file name too. Tree. Send. And it's a lot of code, so hopefully something isn't broken.
XHR2.
Oh, thanks. I knew I was going to do that. Let's save this. Okay, so
Time out.
oh, sure.
Give me a second.